What's up guys, welcome back to this channel. In this video tutorial we are going to solve another important question regarding binary trees, which is a reverse level order traversal. So let me write here what question we will be solving today. So we will be solving a question. Okay, so let me explain. Reverse level order traversal. So let me write in the short LOT. Clear? So in the previous video sessions I have discussed many number of questions like pre-order traversal, post-order traversal, in-order traversal, vertical order traversal, as well as a label order traversal. So we have already discussed the concept of a label order traversal. If you have watched that video, I think it is quite easy for you to solve this question to calculate the reverse label order traversal. So it is very easy to calculate label order traversal. You can check that video, the link is in description, and make sure you are watching all the videos in the series of this Shivaya tree series. And in this video we will be seeing the reverse label order traversal. So it will be a label order traversal. We will use the trick same as it is. So let us see how it look like. So let us suppose I am creating a binary tree here. This is my node 1. Let's say its left children is 2. Let's say it having right children 3. Let's say it having a left children 4. And it having a right children as a 5. So if I talk about the label order traversal, not about the reverse label order traversal, if I simply talk about the label order traversal, this is my first level. I consider it as a first level. This is my second level, and this is my third level. Okay, so what will be the label order traversal? Let us see. So see, if I talk about the label order traversal of this binary tree, it will be, first of all I will take this node from the topmost level 1 as in my answer. So I will take it. Now I go to level 2. In this level 2 I will go from left to right. It is very important. I am going from left to right. In each level I am going from left to right and picking the nodes. So I will pick a 2, then I will pick a 3. Okay, so I will take a 2 here and I will take a 3 here. Then I go to here, I take a 4 and then I take a 5. So I am going to each level and then I go traverse the nodes from that particular level from left to right, and that thing is known as my label order traversal. That thing is known as my label order traversal. So what about the reverse label order traversal? So let us see how the reverse label order traversal look like. So let me explain how does it look like. So basically in the reverse label order traversal, we will move from the bottom. We will start traversing. The concept is same. The concept is same that for each level we need to traverse from left to right. Okay, for each level we need to traverse from left to right and take all the nodes in our answer. So the concept is same, but in this case what we need to do is we need to start from the bottom. We take a bottom level, so it will be a third 3. So we will take the nodes 4 and 5 from this level. So let us take it into the answer. Then we go to the above level, which is this 2, and again we will do the same thing, that is we are taking the nodes from left to right of the current level. So 2 and 3 will be present here. So I will take a 2 and 3 in my answer. Then I go to the above level, which is a 1. There is only one node, so I can take this only one node here. So this will be the reverse label order traversal. So what is the main difference? The only difference is, in case of a label order traversal, we are starting from the level 1 and then we are going downwards, and for each level we are taking the nodes from left to right and adding it to our answer. But in this case, in reverse label order traversal, what we need to do is we need to start from the bottommost level. So bottommost level we need to start from this, and the concept is same. We go from left to right and take all the nodes, but we need to start from the bottommost level. So this and this level will be covered. So I hope you understand. So let us see how will we be solving this question. So let us understand. So let me take a let me explain with you and quickly erase all this stuff. So about how to find out the reverse level order traversal. So see, what we need to do is, for example, let me again draw the tree. This is my tree. This is a node 1. This is a node 2. This is a node 3. This is a node 4. And this is a node 5. As in the starting of the video I told you, if you know how to calculate the level order traversal, then it is very easy for you to calculate the reverse level order traversal. So for calculating the reverse level order traversal, we also using a queue data structure like in case of a level order traversal. So let me create a queue here. So I am creating a queue here. This is my queue data structure. I already discussed how queue works in the previous video of a level order traversal. So this is my queue. So how does the reverse level order traversal works? First of all, let me remind, in case of a simple level order traversal, what we will do, we take the root in an answer. Then we check, is there any left children of this root? Yes. If it doesn't exist, we simply add this into the queue. If it's any right children of this root? Yes. If it does exist, we simply add it to the queue. And then what we will do, we remove the topmost element of the queue, or we can say the element present in the front of the queue, and add it to our answer. We repeatedly do this process. Continuously, repeatedly we are performing this task until our queue is not empty. Okay. So, but in this case, what will be changed only? The only thing changed is, let us take, I am taking a vector here, v vector. In this v vector, I am taking my answer. So, how I will get answer? Let us see. So, my answer will be, first of all, it will be a 4. Then it will be a 5, then it will be a 2, then I go to the 3, and then I go to the 1. Means simple level order traversal, I am going from left to right in each level, but the only difference is this is a reverse level order traversal, so I need to start from the bottommost level. Okay, so this is the huge difference here. So now see what I will do. First of all, we in this case, first of all we go to right, then we will go to the left. Okay, I will explain the intuition behind this. So one thing you need to remember is, in case of a simple level order traversal, first of all we check for the root to left children, but in this case we will first of all check for the root to right children. Okay, so this is very important. So what I will do, I will simply add this root into the queue. So let us add this root into the queue. So I have added this root into my queue. After adding this root into queue, first of all what we will do, when the process continues, as you can see, the front is here, my front pointer is here, front pointer is pointing to this. Okay, so let us see what I will do is, whatever in the front of the queue, until my queue is not empty, whatever is in the front of the queue, what I will do, I will simply remove it. So let us remove it. So I will simply remove this from the queue. This is removed, and when I remove it, it will be out. So I can say that 1 is out. I will check what is there any right children of this one? Yes, it does exist, which is a 3. So what I will do, I will simply add this 3 into my queue. Then after that I will check, is there any left children of this one? Yes, it does exist, it is a 2. So then I will add this 2 into my queue. So the main difference is that, first of all, in reverse level order traversal, I am taking the right children, then I am taking the left children. But in case of a simple level order traversal, I always take first the left children. So after doing this stuff, now this node is explored completely. If you carefully see, I have taken all these children. So what I will do, I will simply add it to my vector. So let me add it in the vector. Clear? So next step. So here I am having a 3 in the front of the queue. So first of all, I will remove it from the queue. So let me remove it from the queue. So when I remove this from the queue, so it is removed from the queue, let's suppose. So when I remove this from the queue, the front will be pointing to what? I remove 2 from the 3 from the queue, which is the right children of 1. So the front will be pointing to this 2. Now I will again check for the 3. Is there any right children? Always remember, in case of a reverse level order traversal, first of all I will check for the right children. So there is no right children, as you can see there is a null, as well as there is no left children. So we have searched for this left as well as the right children. So we will simply add it to our answer. So let us add it to the answer. Okay, now we will see 2. So what we will do, whatever in the front of the queue, simply remove that. So I will simply remove this. When I remove this, front is not pointing to anything. Okay, so what I have removed is 2. I have removed the 2. So let me write here. So again I do the same step. I will check for its right children as well as the left children. So is there any right children of a 2? Yes, it does exist. It is a 5. So simply do what? I simply add 5 here. So when I add 5 here, the front will start pointing to what? 5. Of course, because front points to the first element. And then I will check for the left children. Is there any left children? Yes, it does exist. It is a 4. So I will add this 4 into my queue data structure. So let me add it here. I have added 4 here. Now this node is completely explored. So I will simply add it to the v vector, or you can say answer vector. Any vector you can take. Clear? Any name you can give. Now again what I will do, whatever in the front of the queue, simply pop it out. So whatever is in the front of the queue, simply pop it out. When I pop it out, it will stop pointing to this, and it will start pointing to this 4. And what I have popped is, I have popped current element is a 5. So I will again check, is there any right left children of this? No, there is no right children of this 5. Here is a null, if you can carefully see. Is there any left children of this 5? No, there is no left children of this 5. There is also a null. So what I will do, I will simply mark it as explorer. I can say that is explored. Simply add it to my answer vector, or any vector you can say. I am taking it as a simple data structure. Now whatever, again we will simply repeat this process until our queue is not empty. So again, if you can carefully see what is in the front of the queue, in the front of the queue I having a 4. So simply I will remove it from the queue. When I remove it from the queue, front is not pointing to anymore, because there is nothing present in the queue. So what I have popped is, I have popped 4. So I will check for its left children as well as the right children. So there is no left children of this 4, as well as there is no right children, as well as there is no left children of this 4. So this is also completely explored, and I will do is, I will simply add this into the answer. After adding to the answer, now when I check, the front is not pointing to anything, because the queue is empty. Because now my queue is empty, so there is no element in this queue. So can I say that now my task is done? So this is the, but one thing you need to remember, this is not a reverse level order traversal. Okay, this is not a reverse level order traversal. What you need to do is, you need to reverse it. You need to reverse it. When you reverse it, you will get your reverse level order traversal. So let us see how we have done this. So when I reverse it, it will become 4, 5, 2, 3, 1. 4, 5, 2, 3, and 1. And this is our final answer. So what is the stopping condition? The stopping condition is same like in case of a level order traversal, that when a queue become empty, there is no element present in the queue. So all the elements, it means, are explored. So what we need to do is, the elements or the nodes present in this vector, we need to reverse only. We need to only reverse it. And when we reverse it, this is our original answer. So how it is our original answer, let us see. So first of all, we need to go to the bottommost level, which is 3. And in this level, I will take a 4. As you can see, 4 is taken. Then I take a 5. As you can see, 5 is taken. Then I go to the above level, that is this second level. And from the left to right, I take a 2. So 2 is taken. Then I go to the 3. As you can see, 3 is also taken. Then I go to the level 1. When I go to level 1, I need to simply take this 1. And as you can see, our answer is this 4, 5, 2, 3, and 1. So this is how we can calculate the reverse level order traversal. How to find the reverse level order traversal of the binary tree. It is quite similar to the level order traversal. If you understand the level order traversal, then it is very simple. So let us see the code of it. So here, first of all, we have described the node structure as we usually do in every video. Then we have simply defined a create function to create a node to simply create a binary tree, not a node. Then we having a function level order traversal. I have just modified this function code, so I'm not changing the name, but this function works like a reverse level order traversal. So I can add a reverse here only. The functionality is similar, but I quite changing this. Clear? So let me write a reverse level order traversal. So first of all, I have created a tree and then I'm calling this function level order traversal, reverse level order traversal, passing the root node. So I'm passing this, you can say this root node. Okay. So after that, what I have done is I have created a queue of node types as usually. I have tell you that we use a queue data structure. Then we have taken this vector as a name of ANS. So instead of printing the elements, I am storing the elements into this vector. As I told you, I am storing the elements in this vector. After storing element, in the last I need to reverse this vector. Okay, so I am storing this in this. Then I push the root element. While my queue is not empty, we need to continuously repeatedly do the same process of taking the front element, pushing it into the answer vector, which is this, and checking and popping the queue and checking is there any right children of that particular node which we have previously added to the answer. First we go to the right. Okay, I'm currently here. First right, and then we go to the left. Second left. Is there any right children added to the queue? Is there any left children added to the queue? And finally, when the queue is empty, what we have done is reversed the answer vector, which we have done here. So we have reversed the answer vector. After reversing, whatever the elements of the vector, that will be my answer. So I will simply print that. So let us create this binary tree. Let us create this binary tree and check out, is it giving a right reverse level of traversal 1 2 3 4 5. Okay, so first we having root node 1, it having left children 2, 2 having left children 4, and 4 having left children nothing, right children nothing, and 2 having a right children 5, 5 having a left children nothing, right children nothing, and 1 having a right children as a 3. So 3 having a left children nothing and right children nothing. So let us see. Four, 5, 2, 3, 1. As you can see, this is the reverse level of traversal of a binary tree. Here is the same. So I hope you understand the concept of how to calculate the reverse level of traversal. It is very important question on the point of a interview point of view. So I am making all the important question video. Make sure you are subscribed my channel and also press the bell icon. So it takes a lot of hard work for me to make such kind of videos. So meet you next video. Till then, bye bye.